Okay. Okay. Am I audible?
Yes, sir.
Okay. So first of all, we want to understand that if you have some doubt, it will be completely on basic problems. Okay. So whether you have any doubt in structure related memory allocation, structure and union, um, like how memory is being allocated, why word size is considered. Do you know it that what is word size? Is it known to everyone?
No, sir.
No, sir.
Okay, so in case of structure variable, if we say that we are declaring a structure variable having integer, one integer member, one character, and one short. Okay, we are taking different data size because we know that in case of integer it will be 32-bit, in case of short it will be 16-bit, and in case of character it will be 8-bit. Okay, so if we allocate memory for this, then what should be the size of this structure? 4 byte, 2 byte plus 1 byte, so it should be 7 byte, but actually it will vary. I will show you that how it is varying. Okay, so let me log in.
Sir, what is the difference between this workstation and VMware? I mean, VirtualBox.
Almost same. There is no difference. I just need a Linux environment, that's why I'm using it. Okay, so okay, let me write a program. I think the font size needs to be increased. Zoom in. Is it visible?
Yes, sir.
Okay, so let me create a directory. uh, Sample codes. So here I'm going to write my first program. So say this is test.c. Okay, or instead of this I will write struct or structure.c. Okay. So in this program we are going to declare a structure variable. So stdio.h That's sufficient at this moment. If some additional header files are required, then it will be added later. Okay, so in this one I'm going to define a function. Okay, so as you are already familiar with type def, so let me create a structure variable type def struct. Say it's a demo. In this structure variable we have one character variable, we have an integer variable, sorry, we have a character variable C, we have an integer variable say I, and one short, this is S. Okay, so so I'm going to create this demo structure. So here I want to print the size of this structure. Okay, so if I want to print this value, it's simply printf %d, it's a size of, and I want to print the size of this structure, so struct, or we can use simply demo. Okay, now I'm going to print this value. So what should be the output? I'm going to compile it and then I will run it. Can you see that the size of it is returning 12 bytes? Okay, but how? This value, we expect that this value will be only, what should be the value? Its value should be 7 bytes, but the here the value is, as you can see that the value is 12. This is not as per our expectation. Okay, so what's the reason? I'm going to open this file. Okay, you can see that this value is this is the value, but character is taking only 1 byte, integer. Like now, so prove it, we have to print, let me print the size of other members. Okay, so instead of demo, first I will print the size of int, then say I will print the size of character, and I will print the size of short, then finally the size of demo will be printed. Okay, now I'm going to compile and run this program. Okay, so if I run this program, you can see that the size of int is 4, character is 1, it's 2, but still total memory allocation is 12 byte. I want to change this code. Code means I want to change this order. Okay, so I will write it here. So first I'm putting this character, then short, then int. If I save this code, okay, now if I compile and run it, now you can see the memory allocation is 8 byte. But what we have done, we have just changed the order of the members, nothing else. The members are same, but previously it was character, int, then short. Now it's character, short, and int. Now it's taking 8 byte. Okay, so what's the reason behind it? The reason is memory allocation. Okay, so okay, let me check whether any no graphics packages are not installed probably. Okay, so I will explain it here. Okay, so what's the reason? The reason is, in the previous case, when we are declaring, or at this moment what we have, so character, for character member it is taking 1 bytes. Okay, now so first 1 byte block will be allocated for this character member.
Sir, can you increase the text size?
Okay, just wait, I'm going to close it without saving. I can share my screen here. Okay, so how this memory is being allocated? The memory allocation is like this. So for character variable, so in system, memory will be allocated in multiple of 4 bytes. Okay, it will be allocated in multiple of 4 bytes. So in this case, at this moment, what we have, so first 4 byte is being used, sorry, first 1 byte is being used for character variable. So this is for character variable. This is for character variable. After that, next 2 bytes will be used for the next member is, which one is next member? Next member is short. So next 2 bytes will be used for this short. Okay, so next 2 bytes will be used for short. Now we have to check whether this next 2 bytes will be allocated here or it will be allocated from the mid of this portion. Okay, so just to understand, let me show you that this one is being allocated here. Okay, so this is short member and this is the memory allocation for integer. So integer is taking 4 byte. So here 1 byte is allocated for char, 4 byte is allocated for int, and here 2 bytes for short. Now let us check that what's the memory allocation. Okay, but it will be obviously a contiguous memory space. Okay, I have written in separate row, but it's actually a contiguous memory allocation. So what actually happens is, this is the memory allocation. It's like this. Okay, so it will be contiguous allocation. Now let us check that what will be the actual address. Okay, so in this program, now I'm going to print
Sir,
the,
why the allocation will be in multiple of 4 only?
because in my system word size is 4 byte. I will show you, just wait for it. I will show you that why it is being allocated in this way. Okay, now okay, let me create a variable. Okay, because until we allocate memory or until we create a variable, memory will not be allocated. Okay, so let me create a variable. So here I'm going to create a variable, sorry, say, okay, I will declare a variable like demo d1. Okay, after that I will print the addresses of the members. Okay, let me just, I'm just using a separator, nothing else. Then I will prefer to write the address. Okay, so I'm going to print the address of the members. So p size of my variable name is, okay, I'm not going to use size of, my variable name is d1. I want to print the address of d1. Okay, so I'm going to print this address of C, address of S, address of I. Okay, now okay, I can open this code here. I compile it here and run it. Okay, what is being printed? This is the address of character C. Okay, this is the address of S, and this is the address of I. Okay, so how the memory is being allocated? So 8, the next one, so character is taking 8-bit, so 1 byte is being taken by character, short is taking 2 bytes, I is taking 4 bytes. So if the address of C is 808, 08 plus 4, what is that? 9, A, B, C. It is in hexadecimal format. So if we add 08 plus 4, then the value is 0C. So the address of I is 0C. But can you see that the address of short is taking A, 0A. So 0A means 10. So as when we have drawn this, we have pointed some doubt that instead of this, what will be the memory allocation for this member? The memory allocation will be like this. Okay, so the actual memory allocation for this member is like this. So 1 byte is wasted here. So short is not being allocated just after this. Short is being allocated from the mid of it. Okay. Now, why the size of this memory is in multiple of 4 bytes? Okay. So we have to understand this in this perspective. So if I open Windows environment, okay, I'm going back to Windows environment. Here I'm creating a new file. Okay. What will be the size of this file? This is my desktop. What is the size of this file? New text document. It's 0 KB. Okay. Now, if I open this file, if I write only one character, what will be the size of this file? In system memory or in secondary storage, what will be the size of this file? I have written only one character. Previously it was 0. Now, hello.
No idea, sir.
No idea.
So what it should be according to the concept of structure? Okay, so previously as you have thought that it will be 7 bytes, but in reality what is the actual size? It's 8 byte or 12 byte based on the order how you have declared the members. In this case, what will happen? We expect that the size of this file will be 1 byte, but no, actually the size of the file is 1 kilobyte. Okay. Now, if I add 2 characters, what will be the size? Whether it will be 3 kilobyte? No, the size is 1 KB again. So when it will exceed the value of 1 KB, if we write 1024 characters, okay, if we write 1024 characters, when it will exceed 1024 character, then it will be 2 KB. Okay. Now, if I go to this file properties, you can see that what's the size? It's 96 bytes. Okay, this one is showing that the size is 96 bytes, but still the file is taking 1 KB of space. Okay, but still the file is taking 1 kilobyte of space. The reason is it is dependent on paging. In operating system, you will learn the concept that the files are being, if you create a large file, it will be multiple of the smallest unit size is 1 KB in my system. It can vary. In some system, it can be 4 KB. Okay, so actual size is 96 characters, as we have written only 96 characters, but in system memory, one block is being allocated, and this block size is 1 KB. Similarly, in this program, when you are allocating the memory for the variables, it will be allocated in this way. The reason is it makes, so whenever we are writing program, we have to thought of the performance. Okay, so system is managing its memory in this way so that it can fetch the members efficiently. Okay, now I'm going to give you, I want to add one character here. Okay, I'm going to add one more, sorry. I want to add another character here. Say the character name is C, it's okay, it's D. Okay. Now, what will be the size of this?
12.
Okay. If I compile and if I run it, the memory allocation is 12. Okay. Now, in this case, what is happening here? So in our program, if we return here, then another after short, another unit will be allocated. So in this case, the memory allocation is like this. So let me move the items. So this integer is being allocated the last 4 byte, okay, and in between another memory block is being allocated. So this another, I think you can understand that. Okay, so here this character member is being allocated. So instead of int, here one character is being allocated. So okay, this is 2 byte. So one character is being allocated here, home. Okay, this is the another character. It is taking 1 byte, and it is the last one integer is taking 4 byte. Okay.
Sir, in your system, the sizes are like allocated in multiple of 4. Can that vary from multiple system?
This one, it will generally, if you use standard C compiler, okay, then it will be like this. It will not vary system to system, but there are some compilers where memory allocation is little bit different. But in standard compiler, obviously, whether you are using in Windows environment, probably you prefer the Windows software, I forgot the name, but if you use the GNU
MinW.
compiler, GCC compiler, yeah, so in those cases this is the allocation. In this way it will be allocated. It improves performance of the program.
So it is the multiple of 4. It is dependent on the architecture, 32-bit or 64-bit.
It's not directly, obviously it's dependent on architecture, but in 32-bit or 64-bit, in both of this system, the word size is 4 byte. In 32-bit architecture, again the word size is 4 byte. In 64-bit, it's 4 byte. So it will not be multiple of 8, it will be multiple of 4. This is the smallest unit size which is allocated for memory allocation. Okay, so I think you understand that how memory is being allocated.
Yes, sir.
Yes, sir.
Okay. Now let us go back there. Okay. The thing is, here I can open the code. I'm going to close it. I want to create another program using union. Okay. Okay. Better I can copy that code. Instead of structure, here I'm going to use union. So I'm removing this line. Okay. So character short int. So demo d1. Okay. Now tell me that what will be the output. Integer size is 4 byte, character 1 byte, short is taking 2 byte. Now what will be the size of demo? I'm going to compile this program. Okay. Union, and I'm going to run this. So its memory allocation is 4 byte. Okay, you can see the size of demo is 4 byte. So we know that in case of union, it will allocate memory only for the largest member. So size of the memory allocation is for largest member size. So here the largest member is integer, that's why its memory allocation is 4 byte. Okay. Now when we are trying to print the address of C, S and I, can you see that the address is showing same address?
Yes, sir.
Okay. Now if I want to, so we can understand that two members are allocated. One is int, char and short. So in case of structure, what will be the memory allocation? As we have seen that the memory allocation in case of structure variable is like this. Okay, I'm going back, I'm just returning. So this is the memory allocation for structure variable. In case of union, it is allocating only a memory block having 4 byte. Okay, so it will allocate the memory block having 4 byte. So in this 4 byte, if I want to store integer, then the whole space will be allocated for integer. If I want to put short, then the first 2 byte will be allocated for short. So remaining 2 bytes are unused. If you want to put only character, it will allocate this. So first 1 byte will be allocated for character. So rest of the part cannot be used. So simultaneously 2 members cannot be stored in a union variable. 2 members cannot be stored. Even if you think that I will keep character and short, I have 4 bytes of memory, so I will put character and short, because as a whole character and short is taking 3 bytes. So in case of structure, character is being allocated here, short is being allocated here. So in case of union, if we think that this first byte will be allocated for character and this one will be allocated for short, no, it's not possible. It will not be allowed. So only first member can be kept. So only one member can be kept at a time. So let us check. Okay. So here I want to put, I want to keep say the address of C, address of S, and address of I. So here you can see that the addresses for each and every member is same. This is the base address of the union. So if I want to store some value, I want to store some value to member C, and after that I want to store some value for member S. What this S will be allocated? S will be allocated at the same address.
So it will replace.
So it will replace the value of C. So only one member can be kept at a time. That's why in case of union, for each and every member, the address is same. Okay.
Sir, in structure, is there any specific reason why there was one block unit empty after character? Like why the short was not continuous?
No, the memory allocation pattern is, if it requires 4 byte, it will use the whole block. If it's taking half of the word size, it will be either allocated in the first half or second half. It will not be started from any intermediate position. If we declare 2 characters in this program, if we declare 2 characters, like just I'm moving here, if I declare 2 character member, one is C, another one is C1. So first byte will be taken by C, second byte will be taken by C1, then short will be allocated. There will be no space wastage. Okay, but as short is taking half of the word size, that's why either it will be allocated in the first half or second half. The concept is same for integer. So in case of integer, why it is taking memory allocation in this way? So after character, if the integer is being allocated, can we allocate the integer up to this? Okay, can we allocate this integer up to this? Say I have character, one character member and integer member. So if we can use contiguous space, then this integer needs to be allocated just after character and up to this. So it needs to be allocated up to this. Okay, I'm saying that this will be the memory allocation for integer, but it is not taking that much of memory. It is taking 4 bytes, but it will start from next 4 bytes. After this word size, when this word will end, next word will be allocated for this integer. So instead of this, actually the integer is being allocated here. Instead of this, it is being allocated here. Okay, so in case of short, it will take half of this size. And to understand it in detail, you have to learn microprocessor. In microprocessor, you will learn, I don't know that whether the paper is in your syllabus or not. In microprocessor, you will understand that how this actually this memory addresses are being allocated at the low level. In within processor, how this memory is being allocated. So generally we discuss the things in microprocessor. So here it will be difficult to discuss, but for understanding, just you can remember that this is the way how it is being allocated. So if it's a integer, it will it will be allocated in next word. If it's short, it will take half of the word size. Either it will allocate the first half or second half. For character, it is taking 1 byte. That's why it will allocate 1 byte in its position. So if we get a free space, there we can allocate a character. Okay. Any doubt?
No, sir.
Okay. Now, can you tell me that in case of two-dimensional array, okay, one more thing I want to mention here. I want to show you in here. Okay, if I have declared one array, okay, so array of characters, say I have a character array uh, can I write this? Whether it will compile?
Yes, sir.
It will compile. Are you sure? Okay, I will not confuse
Yes,
you.
sir. Yes, sir, it will.
Okay. Yeah, so I'm going to add it here. So I would want to print size of this. Okay. How much byte will be allocated? What will be the size of ERR?
6
bytes.
6 bytes.
It will be 6. Okay. Probably we have written it in this one. So GCC. So let me run it. It will be 6. Okay. The reason is at the end of this string, one end marker is being added. So actually 5 characters are stored, but as it's a string, in system 1\0, which we represent as \0, this special symbol will be added, which will be considered as the end marker of the string. Okay. Now if I write, I'm going to declare another array. Okay. So say this array is ERR1 and this is being allocated as a character. Okay. So first character is H, second character is E, third character is L, fourth character L again, and the last one is O. Okay. How much memory will be allocated for it? I want to print the size of this. Okay. If I compile and run this program, in this case, memory allocation is 5. Because the number of elements present, we are keeping the same thing in ERR and in ERR1. But here, the size is 6 and for the next one, size is 5. Because in second case, the individual characters are being stored in this array. So in different positions, the individual characters are being stored. Okay. Now, I want to add size as well as I want to print the string. In case of ARR, I will print size of the array and I want to print the content of the array. In this case, I will print size of the ARR1 and content of ARR1.
Sir, it may show garbage value because there is no null character.
Okay. So in second case, can you see? In second case, there is no end marker. We can access individual characters. Okay, we can access individual characters, but there is no end marker. That's why the next to these characters, whatever value is there, it can be other variable, it can be anything else. So it will print that value. So this part is garbage. Okay, just to check with this example, let me print after size of, let me print address. Okay, before this string, I want to print address. Okay, so I will use percentile %p. Percentile %p sets address. So I will print address of the ARR. Okay, and here after this I will print address of ARR1. Okay, okay, I will run it from here. Let me open the code. Okay, so after, so this is the memory allocation, this is the address of ARR, this is the address of ARR1. Okay, now this memory is being allocated, this hello, this is the in different run this value can be different because this is the garbage. So after this location, whatever value is stored, that will be printed. It can be a special symbol, it can be anything, it can be a garbage value. It depends on the memory allocation. Okay, so here what happens that after,
Sir, after garbage value, why did it stop? Like after 5 characters?
the reason is, if you can check the address, this is the memory allocation for ARR1.
Yes, sir. The second part is that ARR actually, I guess.
Second part is,
And
yeah, second part is ARR.
it got the null byte.
So after 5 byte is being allocated for ARR1. Okay, so F5 to next 5, so that means 6, 7, 8, 9 A. Now at FA position, this hello is stored, which is ended with the end marker of the string. Okay, that's why after printing the hello for ARR1, it continues printing the memory location for ARR, because the next memory allocation is for ARR variable as per the address allocation. So next 5 byte is allocated for ARR. Okay, so as ARR terminates, because there is an end marker, that's why it will terminate here. That's the reason. Any problem? Is it fine?
Yes, sir.
Yes, sir.
Yes, sir.
So one more thing, why your system is showing the address in hexadecimal form while my system shows in the decimal form, sir?
No. I have used percentile P to print it in hexadecimal form.
Oh, okay.
I want to print it in hexadecimal form. That's why I have used it.
Sir, when the array and array1 gets allocated, like if I don't allocate array, then the value which buffers usually get allocated at the end of the stack, right?
Mhm.
So like if I don't allocate array and then print array1, then can I get the value of the stack cookie?
Can you get the value of?
Stack cookie, that is like which is stored after ESP, like the first number, first integer which is stored on the stack. Okay. Like I was thinking, like stack cookie usually it protects against buffer overflow because it gets compared before and after execution of a program. So like if I can get the value of the stack cookie beforehand, before the program fully gets executed, then I can read that value and again feed that value afterwards. So like if I still overflow the buffer, the system wouldn't detect it. Is it possible?
No, basically, if you have for this, okay, I will show you the actual memory allocation. This is just we have printed some addresses. Okay, I will discuss it in detail with some comments. Just I'm going to start it, so you can just remind me in the next day. I will show you in detail.
Okay, sir.
Sir, can you run the same program with this disabling character array? Like comment it out and then just print out array1.
I will print which one. I will comment.
Comment out array and print array1.
Okay. This is the value. Is it fine?
Yes, sir.
Okay. Just before closing it, I want to show you one more thing, that if I write a program, okay, and how this program is being compiled, what are the steps of this compilation? Whether I have shown you earlier, what will be the steps of compilation? Like I'm going to create one file, say the file is test.c. Okay, now from this test.c file, I'm just adding a dummy code. So hash include it's just print message to print hello world, nothing else. Okay, so it will be just print now. When this program is being compiled, so if we want to compile this program, I will compile this program using, okay, I will just clear the screen. The program is test.c probably. Yeah. So which file is generated here?
Executable.
So from this test.c, the executable file a.out is generated. Okay. Now, if we want to remove this file a.out, I'm going to remove this file a.out. I want to compile this code with some parameter by which name the out file will be generated. So say my file is test. Okay, so here from test.c, test is being generated, which is the executable file. So we can run this program here. Okay, what are the intermediate steps? You have learned of compilation procedure. In compilation there are some steps, during execution there are some steps. Okay, here I am going to talk about the compilation procedure. So from this test.c, when this test file is being generated, which is the executable file, now before this during this generation, I want to save the temporary files which are being generated in intermediate steps. So I'm passing some parameter. So I'm going to save temporary files which are generated. Okay. Now if I compile, if I check, you can see that some more files are generated. So test.c is there, but these are the some additional files which are generated. Test.i, test.o, test.s. Okay, so these are the additional files. So whether you are already aware of it, then I can just skip this.
No, sir.
No, sir.
Okay, so from test.c, here in the left hand side we can see that this is the content of test file, test.c, what we have written. Now from this test.c, the first file which is being generated is test.i. This is the intermediate file. Let me show you so that I can show you the difference. Let me create a preprocessor like hash define, say max 10. Okay, hash define max 10. I'm defining a preprocessor. Now I want to print hello world, then I want to print, okay, it will print hello world, fine. After that I want to print the value of max. Okay, I will print the value of max. So here I am writing max, and along with this I'm going to declare one variable, and this variable is say min. Okay, so I will declare one min variable, say its min equals 1. Okay, so I have a preprocessor directive or macro. Here we have a global variable int. We can declare it as global variable, as local variable, whatever you want. I want to show you with one example. So I'm going to print the value of max and value of min. Okay, so I'm going to save this content. Here I'm going to compile it. Okay, now let's check what will be the value of this. So test from test.c, next file which is generated is test.i. So I'm going to open this file test.i. This is the content of test.i. Go to the end of this. Can you see So the previous lines, all the lines on top of this is basically the content of stdio.h header file. So during compilation in first phase, what will happen? The content of stdio.h, this hash include stdio.h, this line will be replaced by the content of stdio.h. Okay, so it has been replaced by this. After that, can you see? So you can see this line, int min equals to 1, int min is equals to 1. This line is here. But can you find hash define max 10? Did you get max 10? No.
No, sir.
In this program, max 10 doesn't exist. Instead of that, max has been replaced by the value of max. So max has been replaced by 10. But the min has not been replaced by 1.
So, sir,
Min-
basically in the first step, all the preprocessors are replaced.
Yeah. So this is the pre-processing phase. So in pre-processing, from test.c, test.i is being generated. So that's why these macros which we are using in our program, these are known as preprocessor directives. Okay, so this is the reason. So variables are not being replaced at that time, but preprocessors are being replaced. Okay, so this is pre-processing phase. So variables will not be replaced here, but preprocessors are being replaced. Now if I open the next program, okay, so from the test.c, the first phase is after pre-processing, test.i, which is an intermediate file, it will be generated. After generating it, what will be the next file? The next file is this s. Okay, so this is the next file. So this is the assembly level code. Okay, so this file contains the assembly level code. So on my system, based on the system instruction, this code will be generated. In case of pre-processing, the test.i file which has been generated, this is not directly platform dependent, but this assembly level code is platform dependent. If I send you this same program, if you are using different operating system or different architecture, then this file will be different. So this assembly level code, it will be generated based on the system architecture. Okay, so it will differ system to system. Okay, now this is the assembly level code. So just previously we have discussed about, we have just mentioned that microprocessor and microcontroller. So in microprocessor and microcontroller, instead of writing these high level programming languages like C, directly we have to write the program using this assembly level code. I don't know whether according to the new syllabus, do you have microprocessor, microcontroller in your curriculum or not, but if it's there, you will learn 8085, 8086 microprocessors, which are very basic microprocessor in 1930s. Okay, from that time. So here, so this is the assembly level code. Now after this assembly level code generation, the next file, so from this assembly level code, now the code needs to be converted to object code. So this object code is test.o, as I'm using the text editor, that's why the things will not be opened properly, because this is not the alphanumeric file. This is the file having machine level instructions, so it will not be printed in text editor properly. That's why we are getting this special symbols. This is the object code. Now from this object code, the next step is test. This executable code will be generated. The next step, this executable code is being generated. Okay, this is optimized code. So this test which we are going to execute, this test file is the optimized code. After generating this test.o or this object code, now it will be optimized. So redundant instructions will be removed, and many phases are there in compilation. So those operations will be performed, and finally the optimized code will be generated. And this code is test.
Sir, test.o, it is also an ELF binary, so we can directly execute that also.
Yeah, we can directly execute it. Even test.s assembly level code, you can directly execute it.
Okay.
Okay, it's already 5:48, so I'm not going to start any new topic. Here I will show you that how memory is being allocated in the next step. Okay, so when we are writing this program, what are the different types of memory which are associated with this program, and how the memory is being allocated. I will show you those things in detail. Okay, the next point is I've just forgot. Okay, do you have any query up to this? Any place or you have some doubt?
No, sir.
Okay, fine. So okay, one thing I will suggest you, please go through, try to understand what is static file and what is dynamic. So in Linux environment, obviously in Windows environment also, I think in Windows environment you have heard of DLL file, dynamic link libraries.
Yes, sir. These are the drivers.
Okay, when you are writing C program, then obviously there is a concept of, in Linux environment there is a concept of static library and dynamic library. So please go through what is static library and what is dynamic library. In Linux environment I can just show you
So dynamic is like when we don't include the header files and it gets included while runtime using PLT and PLT GOT and all that.
yeah. So static
address gets
yeah,
sir.
continue.
The address gets allocated at runtime. Like if I don't include stdio.h and write the same C code, it will still get compiled. But the stdio.h will get allocated or linked at runtime. Like it will not get linked in compile time. So the I file will be different, I think. Test.i.
Yeah, obviously. So whatever we have discussed, this is related to compilation. We have not linked and So linker, loader, those things are coming after that. So during execution, these linkers, loaders are coming. So those things are not being, so it will be validated during compilation, but it will not be loaded. So loader will not load the required files during compilation. It will be validated only whether this file is present or not. Okay. So here, okay. So .so, I have used something which is wrong. .so .so files are basically the static object. Okay, in Windows environment we have static objects also. There are some dynamic objects. So TLL files, dynamic link library, so they are responsible for that. So try to understand the things with respect to Linux environment. Okay, because it will help you a lot to understand the internals of the system. Okay. Have you checked the content whether printf, where printf function is defined?
Yes, sir.
stdio
In
stdio.h.
STR, sir. In VS Code, there is an option to view the functions.
okay, let me show you that. Sorry. This is the header file we have included. Okay, let me check this printf function. Did you get the definition? I've started searching. So this is printf. This is not the definition. It's not the definition. It's not the definition. Have you find till now the definition of printf function?
No, sir.
We have reached at 95% of the file. Now we are at the beginning again. So we have searched the whole stdio.h header file, but there is no definition. But this is the declaration of the printf file. Can you see this line? This is the declaration of the printf file. But this file doesn't contain definition of printf. You can check it VS Code or Visual Studio. You can check it whether the definition or function body is there, because this is not function definition. This is function prototype or declaration. So what this function is defined? This is the question for you. Why this function is defined?
Sir, in VS Code, it's showing it's there in stdio.h.
Do you get the definition? This is stdio.h.
Yes, sir.
Function is
Yes,
there.
sir. It's there, sir.
Can you share your screen?
Yes, sir.
Just a minute. Okay. Okay. So in Windows environment, they are providing it, but in Linux, the definition is kept in different way. The definition is something different. These header files are containing the declarations. Definitions are kept in different way. That's why I have mentioned static object and dynamic object. So you have to check it for Linux environment. I'm not familiar with Windows at all. So this is the definition. Okay. Okay, so we can end this session today. From today, I will start sharing some problems with you.
Okay, sir.
Okay, sir.
Okay, please suggest me if I need to discuss in different way.
No, sir, it's fine.
Feel free and suggest me that in which way I can proceed it, because this class is only for helping you. Okay, we don't have any curriculum that we have to follow it, so we have complete freedom to discuss in any way. Okay.
Sir, what is the compiler we use in Linux?
Mostly we are using GCC compiler.
So that GCC comes inbuilt with Linux, but in Windows we have to install like third party.
Yeah, we have to install third party.
So does that make changes in html.h?
The major problem with Windows environment is the most of the things are not standard. Like in our student life, we have used Turbo C++. Then there are lots of compilers. So in every compiler, they are defining the things in their own way. Okay, in C there are different standards like C99 and some other standards are there. So they are following the standards and they are defining the things in their way. But in Linux environment, we don't need to install additional compiler because the whole thing is, the Linux operating system is based on this C program. The core components in everywhere. So in every distro of Linux environment, you will get this compiler, because for customization, every time we may need to download the source code and we may customize the code. So that's why in Windows environment the definitions are sometimes different. If you use Turbo C++, you will see that there are many things which are wrong, but still it is compiling and it's executing properly. Okay. Okay. Can you write a program? Oh, I have a meeting right now. Okay. I will discuss in group. So the task will be something like that, that you have to write a program which will read few MB of text file and find that what are the frequency of the words. So it's a plain text file, but the size of the file is few MB. It can be 2 MB, 3 MB. You have to calculate the frequency of the words, like hello, how many times it appeared in the full text. Okay, if there's a word hi, how many times it appeared in that. Okay, I will give you some task. Okay, I will share it. Okay, so I'm closing.
Sir, one
it.
more thing.
Yeah.
Like what is the main difference between using a Debian and an this Red Hat?
the most of the things are almost similar, but the package related things are different if we think from user's perspective. So if you go through the history, then you will understand that what is the difference between this Debian and this RHEL packages. So okay,
Which one do you recommend?
my choice is I prefer Red Hat. I prefer Red Hat. It's my personal choice, obviously. From my student life, I have started with Ubuntu, but I faced some problem even to work with the standard editor, which is VI editor. The in different Ubuntu version, the keys are different, so that's why I started disliking Ubuntu at that time. But and after that, for a long time, I have not used Ubuntu. And always in my system, mostly I use Linux environment for. I prefer Red Hat Enterprise Linux, but RHEL is free, obviously. But for student version, CentOS is the parallel development of RHEL. So I prefer RHEL and RHEL related things. But it's my personal choice, obviously. If you are familiar with Debian or Ubuntu, then it's up to your choice. That's no problem. But in server side, still yet, in most of the cases, RHEL will be preferred. Okay. Ubuntu is more user friendly. User friendly means the people who are familiar with Windows environment, they prefers Ubuntu because the graphical user interface and many things are there which are. So this is the thing, but it's everyone's personal choice. You may start using some of them, then you will feel whatever you feel better, you can use that. Okay. Okay, I have to leave. Okay, I have to join in a meeting.
Okay, thank
Okay,
Okay,
sir.
bye.
Okay, sir.
Okay, bye. Yeah.
Thank you, sir.
you, sir.